my channel. Myself Dinesh. I am studying in Sri Venkateswar College of Engineering. Subject Civil Engineering. Topic Moment of Inertia. In this you have learned about introduction to moment of inertia. Moment of inertia, also known as rotational inertia, is a measure of an object resistance to changes in its rotation. It plays a circular role in understanding the behavior of rotating object in physics and engineering. This presentation will develop into the concept, calculation, and applications of moment of inertia. Moment of inertia is an important topic and appears in most of the physics problems involving mass in rotational motion. Usually, mole is used to calculate angular momentum. We will learn about this topic in the following paragraphs. What is the moment of inertia? The moment of inertia is defined as the quantity expressed by the body resisting angular acceleration, which is the sum of the product of the mass of every particle with the square of the distance from the axis of rotation. Or in the more simple terms, it can be described as a quantity that decided the amount of torque needed for a specific angular acceleration in a rotational axis. The moment of inertia, also known as the angular mass of rotational inertia. The SI unit of inertia is kg per second. Fundamentals of moment of inertia. The moment of inertia of an object depends on its mass distribution and the axis of rotation. It is calculated using integrals in calculus and is represented by the symbol. Understanding the distribution of mass in parallel axis theorem is essential in determining the moment of inertia of various objects. Significance of moment of inertia. The physical significance of moment of inertia lies at the heart of understanding rotational motion and the distribution of mass in a given object. Moment of inertia is a fundamental property of matter that quantities an object rotational to changes in its rotational motion. When an object rotates, its moment of inertia dictates how difficult it is to either start or stop its rotation or change its rotational speed. It depends not only on the mass of object but also on how that mass is distributed with respect to the axis of rotation. Different theorems of moment of inertia. The concept of moment of inertia plays a circular role in the field of physics and engineering, particularly in the study of rotational motion. It quantities an object resistant to change in its rotational motion, analogous to how mass characterizes an object resistant to change in a linear motion. There are two theorems that have been developed to simplify calculation of moment of inertia for complex objects. Let's understand in detail. Parallel axis of theorem. The parallel axis theorem is a fundamental theorem used to calculate the moment of inertia of an object about an axis parallel to an axis passing through its center of mass. According to this theorem, the moment of inertia about a parallel axis is equal to the sum of the moment of inertia about the center of mass of an object, product of the object mass, and the square of the distance between two axes. Perpendicular axis of theorem. The perpendicular axis theorem is another essential theorem that allows for the determination of the moment of inertia for planar objects. It states that sum of the moment of inertia of a planar object about two mutually perpendicular axes lying in the object's plane is equal to the moment of inertia about an axis perpendicular to the plane of the object and passing through the object's center of mass. This theorem is particularly useful for determining the moment of inertia of thin, flat objects like sheets or plates. Calculating moment of inertia. The moment of inertia can be calculated for various shapes such as rods, discs, and spheres using specific formulas derived from the integration of mass of elements. These formulas are circular in engineering and physical applications, providing insight into the rotational behavior of objects. Applications in engineering. Moment of inertia is a fundamental in engineering, particularly in the design and analysis of rotating machinery and structural elements. It influences the stability, strength, and performance of systems such as flywheels, shafts, and beams. Understanding moment of inertia is essential for optimized the design and operation of the system. Advanced concept in moment of inertia. Advanced topics related to the moment of inertia include parallel axis theorem, radius of gyration, and product of inertia. These concepts expand the understanding of rotational motion and provide valuable insight into the behavior of complex systems. Exploring of the system. This concept enhances the comparison of moment of inertia in diverse applications. Conclusion: significance of moment of inertia. Moment of inertia is a critical parameter in the analysis and design of rotating systems, contributing to the understanding of rotational motion and stability. Its application extend across various fields including physics, engineering, and mechanics. A through graphs of moment of inertia is essential for solving complex rotational problems and optimize system performance. Thank you.
Yeah.